Hello, I'm Mark Weisheimer. I am here with the Volt, uh, Chevrolet Volt coolant heater made by Eberspacher, and or forever how the hell you say their name. At any rate, I'm going to be going through how we do some of the things we do when we are setting up to see how we can control this via CAN. This model from the Chevrolet Volt is single wire CAN controlled, and I'm using the CAN Dewey from EVTV that Paulo has designed. It's a little modified. This one has a single wire CAN transceiver hacked into it, and then on this setup we've got, ooh, ouch, that's hot. In fact, let's see how hot that is. We've got the heater running. We've got a Purebird CWA 50 pump. I've got a little bit of plumbing here, a 12 volt supply, a 395 volt Better Place pack, a Jld404 that I'm recording on a different camera. I'm trying to do some screen capture at the same time. This is a little radiator from a garden tractor, a Honda garden tractor. Was a 2-cylinder, 13 horsepower. It's about twice the size of a normal heater core. That's 164 degrees. Now I do not have the fan. 175 degrees. That's pretty hot. No wonder it feels so hot. Let me turn the fan on here, and I'm gonna get a little heat because I can feel. Oh man, that is nice. I am not able to get full heat full time, so you can see in the side camera that on the Jld404 we're on 5 amps right now, 6, it's kind of all over the map, and this thing still puts out quite a lot of heat. That's nice. I wouldn't mind having that in my regular car. So we're down to 144 degrees on the heat there, and I'm just measuring the temperature of the body. This is a metal body radiator, and so it's easy to measure the temperature that way. The Chevy Volt heater has inside of it an NTC 10K thermistor that we could connect to probably the Jld405. This is going to be one that the Jld405 is probably going to be the weapon of choice on, because then we can read the temperature of the coolant. Apparently this can't measure its own temperature any other way than through that thermistor, so we'll do the same thing as we go along. I'm not doing anything with the thermistor today, and we're not going to really get too in depth other than the fact that it does come with that, so we're going to use it at some point. It doesn't take much. It takes the high voltage in. This is some cabling. That's the normal connector that comes with it. I have an extension cable coming over to my DC junction box, and then it requires 12 volts, 12 volt car battery, and then a single wire CAN. And CAN Dewey is great for working with that. We're going to use the CAN Dewey today to look at it, and we'll talk a little bit about how we get to where we're at, and what we're going to look for, and what we're going to try to do. Kerry Manning made a capture from a 2013 Chevrolet Volt in what's called the preheat mode. And that's where the car's closed up, you're going to go somewhere in a little bit, and you want to preheat the cabin. So you can put it in preheat mode. And he did that, got about a 30-second capture. It's about 10,000 lines of data, and it's stuff full of data. So there's a lot to slosh through. This capture has 145 or 148 different messages in it. A couple of them we know come from the heater itself. I can identify at least 2 that come from the heater itself. And then a couple of them are unrelated, have nothing to do with it. And the rest of them are telling it how much power to produce the heat. So with this, you can probably see on the ammeter, this thing's kind of going up and down. About 15 or 16 amps is a full 6 kilowatts. So we barely hit. I think we hit 12 at some point during our playback of the capture. I have GV PC running on my laptop. I'm capturing that. I've got GV-RET loaded onto the CAN GUI, and that's been modified for single wire CAN. I'm using the CAN 1 channel, and Colin's written a little bit of software to allow us to put this in high voltage wake up mode on address 0 by 100, 0x100. That's the hex address for the wake up signaling on single wire CAN in the GM-LAN system. So we've got that built in. It works really well. And GV-RET PC works quite well for going back through and looking at it. On the screen, I have a whole list of the IDs of the messages that are in this capture. It starts at the top of 0 by 100. That's only required once. Once it's sent one time, we can uncheck it. It'll continue to run and do everything it needs. 13FF E097 is the next address. That actually happens to be generated by the heater, so we can uncheck that. The heater, if you turn it on by itself with 12 volt auxiliary, will send once per second at 33.3 kilobits the message 13FF E097, and basically I think that's a live signal, just telling the rest of the system it's there. I think basically there's about a half a dozen or something in that. It's half a dozen to a dozen 13FF messages. I think most of them are other devices. 0x621 is keep alive signaling on single wire CAN, and that's repeated quite frequently. The rest of the messages I think are basically, a number of them are going to be which groups of elements in the heater at what power level. It has basically inside there 4 modules that it can command on and off. 3 of them it commands on and off. The 4th one, it can command a level between 0 and like 750 watts. So for anything that's 0 to 750 watts, it picks the level in between. 750 and above, it picks a group that is equal to 750, and then 1500, and then 3000. So if you want 4500, it turns on the 3000 watt and the 1500 watt together, so you got 4500 watts of heat. And then the rest of it brings up as it's needed to fill in to the top number. We can go through with GV-RET, and we can select and deselect these messages that we're going to send just using the straight capture that maybe somebody's provided us just like this. That's really handy. We can do a couple things like we can select the playback speed in microseconds. I've got it set to 4,000 microseconds at the 4 millisecond pause for characters, and that seems to be just about, when I put it at that seems to play back at just about the rate that I think it was recorded at. It's close. And then we pick which CAN bus we're going to send it to. We're using CAN bus 1 on this modified system, and that's what we can do with this from this program. We can take away these messages. We can add to these messages. I'm going to go take this. I commented that I didn't think the 13FF messages are used. I'm just going to start dialing them out by unchecking them on the screen here. And I've got a couple others. 1047, the 1047 message. I think the 2FC0CB. I think that is the 2F40CB is the actual. I think that's the shut off command, because the way Kerry recorded this, he recorded it in preheat mode for 30 seconds and then issued the shut off command. That only appears once at about the 30-second point in the recording. So I'm going to turn that one off. Let me see if I can find some more 13s. Let's see how. Just watch the amp meter, and let's see if we're seeing a whole bunch of differences yet. I don't see any amp meter, so maybe we killed the whole blasted thing. Here it comes back. It goes in waves like this because it's not on all the time. That's one of my frustrations, that it's not all there. But again, that's part of what we're going to try to suss out here is what's the command that tells it which level of heating to generate. And I took the 13s out and I took the 2, and we're still seeing 10 to 12 amps, which is about what we do. We're still generating quite a bit of heat. We've cooled down because I've been running the fan. I have a giant fan on this thing, and what we're at this point. Now we've come down to about 90 degrees on that now, and it is cooler. And it's easy also to go in here and put them all back in. So I just click all, and they're all going to be sent. Let's see if that brings our heat level up. We'll measure the temperature here in just a minute or so, and we'll watch the average. I see right there we're already hitting 12 again. We seem to be staying on consistent current output again. And part of what this problem is that it does shut down the current. It seems like if you count the messages, this has got 10,000 lines of messages. It seems like at about 2,000 it starts generating some heat, and it seems like at about 8,000 it stops. So we could probably take the first 2,000 out and the last 2,000 out, and maybe have a little more consistent heat. Let me. I just use an editor like Notepad++. I leave in the 0x100, and I leave in the 621C Keep Alives, and there's a 62C, which might have something to do with a Keep Alive. I'm not sure on that one yet, so I'm going to leave it in. You go get a different file. I've taken one and I've trimmed that out, and the way we change that is we go to Load from File. Actually, I'm going to stop our. Before I do that, let's see if we came up any just by. Not really. Not anymore. Let's go over and load from another file that I've trimmed these out. On the screen, you're going to see that I have 2013 volt preheat. I've got a copy and I've got modified. These are different ones where I've trimmed the size, and you can see over here the smallest one, number 5. Let's use it because I've trimmed it the most, and guess what? It puts out the most heat. So what I basically did was watch to see when I was getting current, and and that's all I've done. I have not soused the command structure. I just look at the capture that I have. When is it doing the work that I want to do? And I've just chopped some things in and out of there. So I'm going to pick back up with that one, and let's see if we run any more consistent on the heat. I've probably got it in sleep mode right now, so we'll have to wait for it to come back around and kick off the 0x100 wake up message, which should occur right there, but I don't see any current, so we'll leave the 0x100 in there. Might have it chopped out nuts there. Okay, let's see what we get. Still on can 1. Let's do this. There we go. Speed up the messages a little bit. Double the rate right there. I'm going to go to 3,000. And here we're hanging in at the 6 to 9 amp range more consistently. And let's just watch it out. We loop this one over and over. So we go to the end and start back at the beginning. And I know on this one still, even at the beginning, it cuts down a little bit. But we're running about a third power pretty consistently here. And we go up to about 2/3 power at different portions of it. There it's shut off entirely based on our ammeter. We are picking up some more heat. And I'm going to unplug our fan because it's noisy. And just talk a little bit again about what we see with this. We're back, like I said, we do run more consistent, longer heat with those things trimmed out. And this is the original can capture with the beginnings and the ends trimmed out. I think if you actually look at the data that's in there, I can see a rolling counter that occurs. I can also see that the data fields have far more data at the times that it's on. I can see a group of numbers like the 102. I took a look at some of the 1022 numbers and 1020 numbers, and they had way more data packed in the fields when it was generating heat. So what I'm going to do at some point is now I'm going to take those data fields and I'm going to see if I can see how it's building those numbers into power levels, and I'm going to start generating my own and see what do we need to generate so that we can get full output power, because it would sure be nice, and we're starting to warm up quite nicely here. It sure would be nice to be able to command this thing to full heat all the time. 6 kW would be incredible. It would really be a warm car. Take the battery down, but on some of those cold winter days we had this year, it would be worth it during the drive time. It would be even better to do that in a preheat mode, where we would either set up Jld404 or Canduri or Jld405 to generate a lengthy enough preheat while it's plugged into the charger, because depending on what our charger is capable of and what our EVSC is capable of, we could bring the power in through that during the time and not diminish as much on the drive by doing that. So we preheat the car, and then when we go out, we're unplugging it before we actually head out. But the car's basically warm when we get in it, a fully charged battery, and then we have all the heat we want while we're driving, and we're just limited once again by the battery kilowatt hour capability, but you always are anyway. So this should be pretty cool. Stay with us. We're going to get some more numbers as far as what does data fields do, and how do we build those structures on our own to do what we want and have it doing our bidding as we choose. And that's the next stage and the next step. You always got to get to this point. It's always a pain in the butt to find something to use as a heat exchanger and a pump, and you don't have the thing leaking all over the floor, and it's not freezing on you when you walk away from it. And boy, we're getting some heat now. So it's nice and warm. That's fantastic. And we're back to, I'd say we're back to 150 degrees or so. We're back to 148 degrees. So if we could keep this thing at the 4 or 5 kilowatt level steady, that would keep that temperature even with that big honking fan on it. And you're going to use a smaller heater core than that. That is much larger. This is about 12 by 11 by 7/8 inch thick. It is a copper radiator with a copper body, so it dissipates a serious heat, and more than you would see in a heater core. The heater core's half that size, or maybe even a little less, and that's what you heat your car with an internal combustion engine already. So we'll come back at it as we have more data, as we've broken down this data structure a little bit more. But this is a process that we use to get there, and if you have an interest in doing this, please contact Jack and tell him you're interested, and join our group. We'd love to have you. Take care.